Hello everyone, we are once again back with a new Putnam problem. This is from Putnam 2020 and it's Putnam P2. So here is the view of the problem. The problem says to find out the following summation j equal to 0 to k 2 to the power k minus j into k plus j, choose j. Let's move toward the solution. So here is the solution to this problem. Actually I do feel comfortable with n and r, so that's why I am substituting this k and j by n and r. So equivalently we can say this is equivalently this summation r equal to 0 to n 2 to the power n minus r and n plus r, choose r. Now there is a famous thing about the binomial theorem that this can be simply written as r minus 1 choose r plus n plus r minus 1 choose r minus 1. Now I would like to assume something for simplicity, that Sn is equal to the sum of r20 to n 2 to the power n minus r n plus r, choose r. And we would like to assume another sequence xn by Sn by 2 to the power n, which is simply summation r20 to n 2 to the power minus r and n plus r, choose r. Now we should use the formula as we defined previously. So the following sequence xn equal to summation r equal to 0 to n 2 to the power minus r into n plus r, choose r can be written as summation r equal to 0 to n 2 to the power minus r, and here is n plus r minus 1, choose r, plus summation r equal to 1 to n 2 to the power minus r, and here will be n plus r minus 1, choose r minus 1. I think this is pretty clear. Now if we notice that this thing can be written as summation of r equal to 0 to n minus 1 2 to the power minus r, and here is n minus 1 plus r, choose r, and the next thing will be plus 2 to the power minus n and n minus 1 plus n, choose n, and this will remain as it is. Now if you notice that this thing is actually x of n minus 1, from here we can assure this thing. So from the previous thing we come to the conclusion that xn is equal to x of n minus 1 plus 2 to the power minus n into 2n minus 1, choose n, plus summation from r equal to 1 to n 2 to the power minus r, and here is n plus r minus 1, choose r minus 1. Now we should concern about this thing right here. So let me rewrite only that summation, that is r equal to 1 to n 2 to the power minus r, and here is n plus r minus 1, choose r minus 1. So we can write this as following: summation from r equal to 1 to n 2 to the power minus r, and multiplying 2 and dividing in denominator we get this thing. Now this can be simply written as summation r equal to 1 to n 2 to the power minus r minus 1 and here is n plus r minus 1. Choose r minus 1, and this is simply summation r equal to 0 to n minus 1 2 to the power r, 2 to the power minus r. Choose n plus r, choose r, and here is a half. Now the above thing can be written as half into summation r equal to 0 to n 2 to the power minus r, and n plus r, choose r, and we should minus a term, that is 2n, choose n, and here is 2 to the power n, 2 to the power minus n, because we have add and subtract it from this expression. So from here we should get that this is equal to half of xn. This expression is xn minus 2n, choose n, into 2 to the power minus n. So we must end up with getting that x of n equal to x of n minus 1 plus 2n minus 1, choose n, by 2 to the power n plus xn by 2 minus 2n, choose n, by 2 to the power n plus 1. So from here we can write that xn by 2 is equal to xn minus 1 plus 2n minus 1, choose n, by 2 to the power n minus 2n, choose n, by 2 to the power n plus 1. So we are concerned about this thing right here. Now this thing can be written as 2n minus 1, choose n, into 2 minus 2n, choose n, by 2 to the power n plus 1. Now if you notice that the expression can be written as 2n minus 1 factorial by n factorial into n minus 1 factorial into 2. Now if we multiply n with in both numerator and denominator, we should get 2n factorial by n factorial into n factorial, which is exactly 2n, choose n. So this thing we can write as 2n, choose n, minus 2n, choose n, which should give us 0. So our final conclusion is x of n by 2 is equal to x of n minus 1, or more precisely x of n equal to 2 into x of n minus 1. So from here we can write that Sn by 2 to the power n equal to 2 into s of n minus 1 by 2 to the power n minus 1. So from here we can write that Sn equal to 4 into s of n minus 1. So this is a GP series, so we can write that Sn equal to 4 to the power n into s of 0. Now if we calculate s of 0, that should give us 1. So we can say that s of n is equal to 4 to the power n